All right, so same problem we just did, but this time I'm going to work it in a different way. And I call this the unified approach. So instead of doing two pieces, we're going to work it as if it's one. Now, the pulley only changes the direction of the tension in the string. So what if we had sort of a magic way, and mathematically we can do this easy, we have a magic way to rebuild this thing like this. M1 is attached to M2 like that. And what we've done is we've unwrapped the pulley. So it's sort of like this. And whereas the weight of M2 would normally be here, what we're going to do is we're going to put that right here. W2. Now the tension is an internal force. And so it doesn't affect what's going on, because the only thing that affects the whole system are the external forces. So we don't have to worry about putting that in there. Okay, now we are going to have to put in some weight here. So we got W1, and there'll be an N1 there, and then there's a friction back this way. Okay, so now when we make our free body diagram, like so, okay, then all of our forces, we've got friction here, we've got W2 here, W1 there, and N1 there. Okay, and that's it. That's it. Okay, so let's work it on out, see what we get. So I'm going to start with the Y components. MAY. Okay, now this is for the whole system, and remember the acceleration of the whole thing is actually this way. Let's go ahead and put that on our free body diagram, because that'll be helpful to us. All right, and so when we look at our verticals, then we've got N1 minus W1, and that's equal to 0. There's no acceleration in the Y direction, and we're back to N1 is W1, which is M1G. Okay. Then we can take a look at what's happening in the X direction, MAX here. Now I've got W2 minus the friction is MAX. Okay, not X. I don't need the X on there because it's all the same, just like that. All right. Now, one thing that's a little bit tricky is that this mass, now W2 and F1 are operating on the whole system, the whole thing. So that means my M that I have to use there is M for the whole thing. So I really here we've got M1 plus M2A. Okay, and W2 is M2G minus the friction. Okay, we're going to do something similar with the friction. It's mu times the normal force. The normal force we found was just M1G, so M1G, just like that. And what we're going to end up getting is M2G minus mu M1G is M1 plus M2 onto A. Okay, just like that. Now, that's one equation with one unknown, okay? And turns out when you work out those numbers, what you get for the acceleration there is 0.755 meters per second squared, okay? Now, this actually turns out to be slightly more accurate because we don't end up having rounding errors when we're trying to set up our two equations and two unknowns, okay? That always is going to give you some tiny rounding errors, and this one has fewer of those, and so this is actually, if we looked at more digits, 0.755, blah, 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 the blah, 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 blah part is more accurate on this one, okay? Okay, that gets us the acceleration. It does not get us to the tension, okay? So in order to get the tension, what we're going to do is we're going to zoom in on this piece right here. Now, if we zoom in on that, that's piece number 2. All right, we still have W2 here, but I've got my tension back this way, okay? So now I'm just going to focus back on one of the pieces. I could choose M1 if I wanted to. I just happen to do M2. All right, now when I set this guy up, MAX. Okay, now I've got W2 minus the tension. That's equal to MA, and we already know what A is. And we're focused exclusively on M2 here, so this is M2 there. Okay, so I've got M2G minus T is M2A. All right, so now again, once again, I've got one equation, only one unknown because I already know what the acceleration is. I know what that is, and when you work all that out, guess what you get? 13.6 newtons. There you go. Okay. So I kind of like this way. I think it's a little more elegant. Okay. If you can pull something apart or you kind of, anyway, if you can kind of reconfigure it in a way that preserves all your forces and everything, it's kind of a cool trick. And I'm going to do one more of these kind of pulling a thing, and I'll do it this way, but it can be done the other way as well. Okay. Either way is fine. And you don't have to feel like you have to lock in, oh, I'm always going to do it this way, or I'm always going to do it that way. It's really good to be able to do both, okay? Because sometimes one approach is going to be more convenient. Other times, you're going to need all the nitty-gritty detail of all the different pieces, okay? There we go.